Okay, so we've solved problem one already, and just to review, what we've done is filled in this table using the affinity laws. We've shown that for flow rates ranging from 10% up to 100%, that the Hertz, actually let's just let this guy be 100. So we know it's 60, but we're running this as a percentage. So there we go. So in the variable frequency derived, the frequency is actually changing by this percentage. So we're using relative values, not absolute values. The flow rate, there we are, this being the baseline value for flat out. So all of these are at 100%. And we used our power laws to calculate the speed. So this was just the linear pressure, this was the parabolic or squared, and then power, this was the cube. So we got all that done. Now we're going to dive in with some actual values. So consider a pump, specific gravity of 1, full load discharge, 200 feet of pressure. Here's our power. Now we need to get to the flow rate. Okay, so I'll pause it there and then we'll figure this out. Cool. All right. So I think we've solved it here, but I'm just going to fill you in on what we did for problem 1A on the affinity laws. So what we're looking at is a baseline discharge head. So this thing at full out pumping, this thing's going to be running at 200 feet of pressure and 150 horsepower, and our flow rate is 2970 gallons per minute. Where did this come from? Okay, so we went back to our pump storage before. So water horsepower, this is flow rate. So again, that's our through variable. This is the feet of pressure. That's the specific gravity of water, which in this case is just 1.0. And then this guy down here, the 3960, is our coefficient so that the units work out properly. So to get the 2970, all I did was multiply the 3960, which is right here. So I took that 3960, first I moved GPMs to the right-hand side of the equation and just basically solved for it. So here's 3960 times water horsepower divided by feet divided by significant gravity gives me my gallons per minute. So there's my 3960. I multiply it by the pressure, which is in G4, that's the pressure in feet, and I divide that by the power. I'm sorry, 3960 times the power, yep, divided by the pressure. Okay, so 3960 times 150 divided by 200 equals 2970 gallons per minute. Now, to fill the rest of the table in, what I did, since we've already went to all that trouble of getting our affinity laws filled in, for the ratios, I just multiplied the affinity law value, which in this case at 10% flow rate is 1% pressure, times 200 is 2. Cool. We run all the way down and see that we can get it all the way up to 240 feet of pressure. For our horsepower, our baseline 100% horsepower is 150. Here's our affinity law. So I can take that, drag it down, double check nicely. The 150 comes back right where it should. gallons per minute. I take my flow rates, multiply it by my baseline, 297 for that guy at 10%, all the way down. Cool, and then my 2970 comes back out at 100%, and I will now box that in. And then just for completeness, we did the same thing for hertz. 60 hertz is our full low, 10% frequency at 10% flow. Drag those down, so now we can see what our frequencies are in each case. And again, I pinned that cell I16. So that all is good. Let's do the same thing for flow. Drag that. Take this, copy it, paste it. And then the same thing for horsepower. And this will come out the same. It's just the power times 150. Let's do it that way. Drag that guy down. Oops, what did I do wrong? I forgot to pin G4. Go, give that a couple more sig digs. Nice. Okay, so that's problem 1A.
Okay.
6 minutes. Boom.